So welcome to part 2 of the solution of this fun challenge. By the end of this video we will have joy because the tank will actually be auto-aiming with ballistic corrections and stuffs towards the enemy. And you can even see one of the AI tanks there just starting to move its barrel around. So there's more to do on this, but it's a great starting point and let's get it done. So guys and girls, let's get the rest of this show on the road, shall we? Let's pop into the code and see what else needs to happen. I think we should go as far as the tank turret. And taking inspiration from the tank barrel, what do we need to do? Well, we're going to need something like an elevate method, but it's of course going to be rotate. So why don't we just pop that in? We're going to do the standard thing of doing a find and replace of barrel for turret in the selection. And it's just that, it's utank turret elevate. Now, it's not elevate anymore, it's rotate at a given speed. I'm going to get rid of the comment for this one, I think. We just don't need it here. Relative speed should be clamped. Yes, it should, absolutely, because it needs to be between -1 and +1. Okay, so we want to get rid of anything to do with elevation. So it's rotation change is relative speed times that. That's good. Raw new rotation. In fact, I could do a find and replace on the word elevation, couldn't I? So let's have a look for elevation. There's loads of those, and change it to rotation. Boom. Now let's make sure it reads right. New rotation is the relative rotation dot pitch. That's not really true. It's the relative rotation dot yaw. Now, plus the rotation change. That sounds good. Now, before I even carry on, I'm just going to put a comment here just to mark where I am. I don't like the fact that I can't see what's happening because I have got all these IntelliSense errors, and they are obviously because I haven't declared this over in the tank turret.h. So let me just go do that right now. Tank turret.h. We're going to need to declare that. Now in the tank barrel.h, what did we do? Did we put it in the private or the public? Because we should do the same thing, right? It needs to be public. So let's just take that bit. And in the tank turret.h, just pop in public. It's the same comment about the maximum and minimum. That's going to be a useful thing if people are using the method. And it's u tank turret. That's right. Rotate at a relative speed. Good. So that should stop the IntelliSense complaining, and it does. Fantastic. So let's keep reading. That's where I got to. That's why I put a marker. So the rotation, we don't need to clamp the rotation, so we're not going to bother clamping the rotation, in which case we don't need to call it raw new rotation. We could just call it new rotation or simply rotation. The only difference now is that the rotation doesn't get set as the pitch value inside here. It gets set as the yaw value. So we just, what's the easiest way? Maybe just put a 0 in front. So we get the rotation change, pass it into the F rotator, and that should be good. Now, max degrees per second is complaining. Of course it is, because if we look in the tank barrel.h, we had ourselves a nice blueprint exposed max degrees per second of 5 on the barrel. So we're going to want a very similar thing on the turret in the private section, because we don't want another method to be able to call this, another class rather to be able to call this method. And there it is. So that's set up a sensible default. Let's compile away and make sure that this all works. And indeed, that on the tank turret, we have what we have on the tank barrel. The barrel has this set up with these 3 parameters. We should have a setup section on the turret in a moment with just 1 parameter for the maximum speed. Now, something's gone wrong. I've missed a simple semicolon. Always doable. There you go. You see how I use the compile time to do something else useful, to take me somewhere else, prepare for what I'm going to do next. And that way, if the compile succeeds, I'm already where I want to be. There you go, that's worked. And now the barrel, if I go to it, the turret rather, it has this max degrees per second. We'll leave that at 5. That's all good. I'm going to ignore that. That's an old compile failed log. Let's play the game, make sure it works. It does. So the barrel elevates, but of course it doesn't rotate yet. So why not? Well, I think the simplest way to follow this through is let's follow it through from the start, right? The tank player controller is the very beginning of all of this. Does this have anything that talks about barrels, etc.? No. So what do we do in the C++? Well, we aim at every frame, and what we should really be doing here is popping back to our stack that I showed you a few videos ago and saying, okay, what happens? So the player or AI controller does an aim at a hit location on the tank. And then the tank tells the aiming component to aim, and then we call the barrel, and of course there would be a corresponding call down to the turret. So we need to start in the aiming component. That's where in the stack we want to be starting. That's why it's useful to draw yourself a diagram sometimes. So here's the aiming component, and down the bottom here we have the concept of barrel elevate. Well, how about we have turret? Now, do we even have a turret on here? Well, I think we put it in, but let's check. Yep, we do. Great, so we can say turret, rotate, go turret, and it's going to be the delta rotator that we calculated above, dot yaw. See if this works. I don't expect it to work perfectly, but I'm hoping that we will be pretty close. Let's just check that that turret actually has a implementation of that yaw. It does. That's all good. So let's try it. Let's have a go and see how we do. So pregnant pause while it compiles. Oh, look. Okay, I'm too excited about that, but look, that's really cool. I think that elevation speed is probably reasonable, but I don't think that the rotation is reasonable. So what I'm going to do is I'm going to go find a reasonable value here in the blueprint. So I'm going to binary search for it. So we've got 5 degrees, right? Well, how about we go 45 degrees per second? 45 degrees per second, remember. Compile that because it's quicker than compiling C++. I would say that's crazy fast. So let's chop in the middle. 5 plus 45 is 50, divided by 2 is 25. So 25 is in the middle of the two. Let's try that figure. Oh, it's still fast, but you know what? It probably is okay. I don't really know how fast a tank moves, but that's probably okay. I think that the barrel maybe is quite a lot slower to go up and down than it is to go round and round. Yeah, I think that's okay. I think to bring it in line, I'm going to tweak the speed of elevation on the barrel to 10 degrees per second. And then try that. Yeah, that's fine, I think. I mean, we can play with this till the cows come home, but that's my new set of sensible defaults. 10 on the barrel degrees per second, 25 on the turret. I'm going to push those back to the C++, and then I'm going to explain what that means. 10 here, tank barrel.h, sorry, that's 10, and the turret.h should be 25. Okay, what I mean by this, by pushing the values back to the C++, is if the designer comes along and puts another tank into the scene, like so, the question is, what values does this guy now have? If we were to inspect that tank, and then to look at his turret, and say, well, what's the degrees per second? It's going to come with the C++ default. That's the reason that I am setting it in the C++. It is overridable on a tank-by-tank basis, but I'm setting it over there, okay? So that's what I'm doing. Where was that tank I just put in? Oh, right there. Let's get rid of it because it'll be confused with the player tank. Look, we have success. We're aiming at that tank, we're aiming at the hill, we're aiming high up the hill, we're aiming potentially at the other tank. I think that we've got a pretty high projectile speed. I think this would be more convincing if we were to go to the tank itself, and then go to the launch speed and set it at, say, maybe even 1,000. That's far too slow, 1,000 centimeters per second, 100 meters a second, about 250 miles an hour is too slow for a projectile. But let's just take a look and see how much more obvious it makes the movement. You see what it's doing here is it's saying, well, I can only get the projectile about that far away in the world, and if I try and go any further, it's going to ignore me. So that is clearly far too little. We want to be able to fire out to about the periphery of the world, so we need to binary search the projectile speed. Let's try 4,000. By binary search, I mean try a value, try another value, split it in half. So one way to do it is just to go diagonally until it stops bothering to update. That's okay. Actually, that's about right, that 4,000. Yeah. Stops bothering about on the boundary. So we can, from the middle of the play space, about get to the edge of it, which is pretty cool because we don't want to be able to hit it anywhere from anywhere. There wouldn't be any point in moving then. So we want to have to move towards the other tank, navigate some obstacles, and then shoot. So that is open to further tweaking later, but 4,000, as a default launch speed, if I can leave it alone, is a good starting point. I'll pop that into the tank header file. as a new default rather than 10,000. We had a to-do to find a sensible default. That's done. While we're here, let's go to all of our to-dos. In Xcode, you can just, rather than going view task list, you can just look for to-dos. We're still asking the question whether or not the tank aiming component needs to tick. It probably doesn't. We don't have a tick method in here. So what I'm going to do is I'm going to say false and then just test that the aiming works. Let's test that the aiming works before we remove the to-do. It's quite important how you handle these minor things. If you delete the to-do first, then you may lose where you are. At least we've got the to-do in here as a safety net. Now, does it still work? Oh, it's not compiled. Come on, compiler, you can do it. So without the tank aiming component ticking, what happens? It still works. And that's fine, and that's because this method is being constantly called from the player controller. So there's no reason for the aiming component to tick, so we can remove that to do, and then we're nearly there. Let's just look at the other part of the task list. Report bug. Oh, I did that. I did that yesterday. That was reporting to the Unreal answers place about this bug. Now, there's a link to that on the previous lecture, actually, on the lecture where I talked about this, about how to report bugs. So that's all done. Everything's cool. I'm going to save that. I'm going to save all on Unreal, making sure they get rid of all these stars, and then commit my work, and we are done. Well done, guys. Let's move on to something more exciting in the next video.